Hello everyone and welcome to section 4.6. Today we're talking about something called Cpctc. Well, Cpctc is just an acronym that we are going to use this year. It represents the phrase corresponding parts of congruent triangles are congruent. So it's just a shorter way of saying that really long phrase, because to have to say corresponding parts of congruent triangles are congruent every single time would be really tedious. So instead, we take that long phrase and abbreviate it as Cpctc. And it really is pretty simple. It just states that if you have two triangles that are congruent to each other, for example, like ABC and DEF over here, if these two triangles happen to be congruent to each other, then all of the angles and the sides are also going to be congruent to each other. So whatever angles correspond to each other, those angles are going to have the same measurements in both triangles. And whatever sides correspond to each other, those sides are going to have the same length. For example, you can see that AB is congruent to DE. You can see that BC is congruent to EF, and you can see that AC is congruent to DF. You can also see that angle A is congruent to angle D. Angle B has two bubbles and is congruent to E with two little arc bubbles. And angle C and F both have three little arcs inside of them, so they are congruent. And you can see all that lines up. A goes with D, they're both the first letter. B goes with E, they're both the second letter. And C is congruent to F, and they're both the third letter. That's going to be really important as we go through this, is this congruency statement lines up and matches. So if you have to write your own, you got to make sure that you're writing it in a way that fits the statement to make the triangles go together correctly. So let me go ahead and zoom in a little bit here on example 1. Example 1 says list all the congruent angles and write a valid congruency statement for this. So we're going to list all the congruent angles and all the congruent sides and then write a valid congruency statement. So the first thing I'm going to look at is angle P right here. Notice how angle P has one little marking, and angle H also has one little marking. So we can write that angle P is congruent to angle H. Notice again that I'm only using one letter, and as long as there is no confusion as to what angle P and H are, we're allowed to use one letter. But if these two triangles are connected, we have to make sure that we're using three letters to name those angles. The next one, you can see angle T has two markings. Well, the other angle that has two markings is G, so we're going to call it congruent to angle G. And my last one is the one with three markings. That is going to be angle W. Angle W has three markings, so it's going to be congruent to angle D. That also has three markings. When I come over to talk sides, we got to be careful because I want to say that side PW is congruent. Well, the other side that has P has one marking is DH, but if I started with P and went to W, I went from 1 to 3. I went from the angle with one marking to three markings. P corresponds to H, so PW is not congruent to DH. PW is congruent to HD. You want to make sure that you go in the correct order when you do these. Put my little segment lines on there. So I went P to W, now I want to go P to T because that's the one with two markings. So P, T, well we already know that P corresponds to H. So if we're going P to T, then we're going to go H to G. So PT is congruent to HG. Again, they both have two markings, so we can see that's clear. P and H both went first, and P and H both have the one angle tick mark. So we're going to put P and H first, and they both went to the one with two angle marks, so that's going to be T and G going together. And it looks like my last one is T to W. So segment TW is congruent to. T has two angle markings in it, so it has to go with G. And the one with three markings is G to D. So T and G go together, D and W go together, so TW is congruent to GD. And now to write my valid congruency statement. Well, since P, T, W is counting up, P has one marking, T has two markings, W has three markings. We know that triangle P, TW is congruent to, and let's make sure we count up on the other one. 1 is H, 2 is G, and 3 is D. So that is the way we have to write it. Now, when I say that is the way, you could also write it as TWP, as long as you write this one as GDH. You can write it as DGH as long as you write this one as WTP. They just have to go together. The letters have to line up in the correct fashion. And it makes it really easy when you look at something like example 2. Now, example 2 is a really easy problem to do once we understand the setup and the logic behind how the congruency statement was set up. They told us that triangle KPM is congruent to triangle AYC. So if we want to complete the following, it's really easy. Segment KM, well, since K is the first letter and M is the third letter, it is going to be congruent to segment AC. Notice that it's still the first and the third letter. So segment AC. Says segment CY is congruent to, well, CY is the third and the second letter. CY goes with MP. PK is the middle and the first. That is going with the middle and the first, which is YA. When I come over here to my angles, these two are also super easy, the ones with just one letter. Angle Y is in the middle, so it goes with angle P, also in the middle. Angle K is the first letter, so it goes with the first letter in the other one, which is angle A. Here they threw it up and started saying, okay, well now we're gonna use 3 letters. We're gonna specify the angles using the 3-letter combinations, which is a little bit more specific. Same idea though. ACY. A is first, C is last, Y is middle. Let's set that up the same way then. First, last, middle is KMP. So angle KMP. This one says triangle MPK is congruent to, well, triangle MPK is just going backwards, third, middle, first. So triangle CYA. Notice I'm just keeping the same symbols too. This was a triangle, so this is a triangle. This was an angle, so this is an angle. These were segments, so these are segments. This is triangle YAC. YAC is middle, first, last. So it's triangle, the middle is P, the first is K, and the last is M. Super easy when you understand that the congruency statement tells you a lot of information. It tells you what goes together and what corresponds with each other. That brings us to example 3, where we could actually throw some real numbers into this. So before I even come over and do any of this over here, I want to get where these real numbers are supposed to go. So in this case, you can see that ST goes with BF. Well, in my picture, I can see that S to T is 17 centimeters, meaning B to F, since they're the 2 first letters. S to T is 17, so B to F is also 17 centimeters. Here I can see that SW is 9 centimeters. SW is the first and the last, so if SW is going to go with BN. So since SW is 9, B to N is also 9 centimeters, which I think makes the last one pretty apparent. FN is the last 2, so it goes with TW, so 14. This is also 14. And then we can look inside. S is 67, so S goes with B, so if S is 67, B is 67. N is 82, N goes with W, so if N is 82, W is 82. And we have one missing angle in each of these. Well, that's pretty easy to find. We know that these triangles, the triangle sum theorem says they have to add up to 180 degrees. So I'm gonna add these two measures together, 82 and 67, and then subtract it from 180. So I get 9, 149, take 180 and subtract 149 from it, and it looks like I get 31. So if angle F is 31, angle T is 31. Now these are really easy to fill in. BN, well, BN we said was 9 centimeters because it corresponded to WS. I think I said that backwards. SW, BN goes with SW. The next one was TW. Well, because we knew that TW went with FN, FN was already 14, so we know TW is 14. I'm kind of just pointing out how we got there, but I think because we did all that hard work in the beginning, the rest of this is really easy, right? We don't even need to look at the other one. BF, we already said, was 17 centimeters. The measure of angle W is 82 degrees. The measure of angle B is 67 degrees. And the measure of angle F we determined was 31 degrees. And that brings us to this final example on here. The final example says if we have triangle DEF is congruent to triangle JKL, and we know that DE is 18, EF is 23, DF is 9x minus 23, JL is 7x minus 11, JK is 3y minus 21. We want to find the values of x and y. Well, let's think about what we have here. I know that DF and JL both are parts of this triangle, right? DF is 9x minus 23 and it's from the first triangle, and JL is 7x minus 11 as part of the second triangle.
Teachers, pardon the interruption. Just a reminder that today is club day. There will be testing starting second period, so announcements will not be made to release clubs. Please go to your class first, students, take attendance, and teachers only release students with the colored pass that goes with that period. If you have any questions, please refer to internal or call student affairs. Thank you.
Feels like you're just in school, doesn't it? All right, so wrapping up where we're at. DF is the first and the last letter, and JL is also the first and the last letter. So J and D and F and L go together. So DF and JL, I know those two things have to be congruent to each other. And if those two things, if DF is congruent to JL, then these two equations are gonna be equal to each other. 9x minus 23 has to be equal to 7x minus 11. So I'll start by subtracting my 7x from both sides. This will cancel, and I get 2x minus 23 equals negative 11. Don't drop that negative in front there. Then I can add 23 to both sides. Bring down my 2x equals, well, negative 11 and 23 is going to give me 12. So I divide by 2, and x equals a 6. So there's answer number 1. The second answer said to determine what was determine what y is based off the fact that JK is 3y minus 21. Well, I saw the other thing that they gave me is DE. J and K are the first two letters, and D and E are the first two letters. So I know that whatever DE is, it's going to be congruent to JK. JK is 3y minus 21. DE is 18. So I know 18 is equal to that 3y minus 21. I know that's written backwards, but I want to keep it lined up correctly. We could flip it if we wanted to, if that makes it a little bit easier for you to view. But we're going to add 21 to both sides. Here I get 39 equals 3y. Divide by 3, and I get that y is equal to 39 divided by 3, which is 13. And there are my two answers. So you can see this whole lesson is just about matching things together, matching letters together based off the order they're written in their congruency statement. Hopefully this helps. Let us know if you have any questions. Thanks everyone. Bye.